Hi, I'm going to do a video walkthrough and show you this new activity called Cash on the Cob. Is there a simple way that sweet corn growers can make more money? So first, let me just give you some background. This comes from a recent research paper that came out in 2019. It's referenced in the activity, and it is looking at a statistical model to see if sweet corn growers are maximizing their profits currently and what they can do to make more profit per acre of land that is planted with sweet corn. And a lot of this is based on effects of density. So what the researchers did here is they took varieties of sweet corn that are specifically hybrids bred for resistance to stress due to crowding. And they planted these fields at different densities with that hybrid seed and looked at what that did to production and carried that all the way through for some analyses of profit. So this is the activity. I'm going to just kind of show you, there's some background on the data set. There's quite a few variables that we've included in here and they're all defined. And then there are activity questions. There are 1, 2, 3, 4, 5, 6 activity questions. There's a lot of scope to customize this and do more with it if you want, but I've got 6 questions for you. So the first set of questions here is answering this question of what effect does the density of plants in a cornfield have on the growth of corn on an individual plant. So we're not talking about the whole cornfield here, but we're looking at things like how many ears of corn does each plant produce? How large are those kernels? What is the weight of that corn produced? Those sorts of things, individual level of the plant. So let me go over to the graph and we'll start looking at that. We know that we want to work with density. So I'm going to grab actual plant density. I'm going to plot that. And then I'm going to grab ear number. And since I think plant density is more likely to be the independent variable, I'm going to flip around X and Y here. And so we can see actual plant density on X and number of ears of corn per plant on Y. And then I'm going to add a regression line to make this trend even more obvious. So you can see the greater the density, the fewer ears of corn per plant. So now let's look at ear mass. So I add ear mass and I click over here on my control panel at the right. I click that to be my Y variable. And I look at this trend with ear mass. Same trend. The greater the density in the field, the lower the mass of corn. You can also see an interesting pattern here where there's sort of like 2 groups of points. There's a smaller group above. This may be due to effects of year or site, but we're not going to go into that with this. We're just looking at this basic question here. Move my face over here. I'm going to add another variable, average ear length. And again, this is at the level of the plant. I'm going to click down there. We see the same trend. The more plants per field, that is the greater density, the smaller the ears of corn get. Averaged filled ear length, and I'll put this on Y. This is the average length of the ear that is actually filled with corn kernels, because sometimes there can be a little bit of empty ear in the corn that doesn't have kernels. And you can see same trend, average filled ear length goes down as density goes up. And then we'll look at one more, which is kernel mass per plant. So this is like the total mass of corn kernels per plant. And we see same trend. So in all of these different measures, as density of plants in the field goes up, the amount of corn, the size of corn goes down. So production at the plant level goes down. So I'm going to flip back to the assignment tab for a second and look at our second question here. So question number 2 is asking, does the production level of the individual corn plant determine the overall production of corn in the field? And so I'm going to add a measure of corn production per acre onto that graph that I've made. So I go back here, and this a measure that we're going to take here, I'm just scrolling at the top, is this case production, cases per hectare. This is cases of corn that are produced at the end. So I click show to add that, and I'm gonna go down here to the control panel and add it as Z. So I'm gonna keep the same graph, and I add this variable, and I've already selected the sine bow color scheme here. But what we can see is that the greater the production of the total field, those are in the up here at the top of this scale. So bright red and pink and purple, these are the highest production at the level of the cornfield. And then as we move down into blues, greens, oranges, and this kind of orange red, that's the least amount of production. So what you see here is there is all of the highest levels of production at the level of the cornfield. They occur in this kind of narrow band that actually spans quite a range of density here in the field. And so you can see that there's these kind of high production data points stretch from roughly 50,000 to roughly 100,000 plants per hectare, and so that is this case production. It is not determined, by the per plant production exactly, and we'll explore this a little deeper with the next set of questions. So if I go back to the assignment again, and now the next set of questions is, what is the relationship between overall production of the cornfield and the profit made by sweet corn growers? So to do that, I'm going to go back here. I'm going to get rid of that case production, and I'm going to put case production on X, and then I'm going to put a measure of profit on Y. So I have to go down here and get gross profit margin, or up here, add it. And I'm going to put a gross profit margin on Y. And so for that question of what is the relationship between production of the field and profit margin, well, you can see it's almost a perfect correlation. The more corn that's produced per hectare, the more profit per hectare, and that is got an R-squared value of 0.997. So this is almost a perfect correlation. I'm going to pop back over to the assignment again and look at the next question. So the next question, the next set of questions really is ask us to make a model that shows the level of density in a cornfield, to show what level of density in a cornfield would predict the greatest profit margin for a sweet corn grower. And then we're going to explore that, determine, well, what is that optimum level of density for profit? And then how does that differ from current levels in that we see in cornfields in North America? And what is the opportunity for more profit there? So let's go build that model first. So I'm going to go back to the graphing tab, and I'm going to build this model by putting actual plant density on X and gross profit margin on Y. And the default for this will probably be a linear regression like this. So this is what it'll look like at first. And then if I add a regression line, it'll add a linear fit, which is not a particularly good fit here. And if we add a quadratic fit, this is a significantly better fit. It doesn't explain nearly all of the variance in gross profit margin, but it explains a heck of a lot more than a linear fit does. And so when we look at this model and we sort of trace this line, this line is showing us the predicted gross profit margin for any plant density in a field, and you can see how it makes this curve, which increases slightly as we move through this middle range, and then it starts to tail off dramatically as we move to extreme plant densities. But as we slide along this line, you can see that the maximum profit achieved is this $12,480 per hectare, and it kind of sustains this level from about 69,620 plants per hectare all the way over to 73,890 plants per hectare. So the model is predicting somewhere in there is the highest profit margin, and it's predicting a profit margin of $12,480 per hectare. Now, this becomes interesting, and some background that's given in the activity is that the actual sort of typical density that is observed in farm fields is somewhere around 58,475 plants per hectare. And you can see that the model predicts profit there of only $12,210 per hectare. And so the difference between that and the optimum in this model, which is somewhere up here, 12,470, that indicates that on average, corn producers could be producing an extra $270 per hectare if they planted at higher densities that are more in accordance with this model. Now, note to teachers, this result is just slightly different. The actual numbers are slightly different from what you see in the published paper, but they use a more sophisticated linear mixed effects model. We're just using this simple quadratic regression with these two variables, plant density and gross profit margin. I think still students will get the same message, and qualitatively the results are the same with this simple model that they can build in Data Classroom and the more sophisticated model that the authors of this paper actually published on. But that's it. That's a walkthrough through these questions. Hope you enjoy this activity and hope your students get the chance to learn from it. Thanks for watching.